Beneath the thin light of a dying sun, the world of Mars lies in silence, a silence older than memory. Its surface glows a muted red, like embers long after the fire has gone out. Dust drifts endlessly across broken plains, gathering in dunes that have not shifted in 1 billion years. Towering cliffs rise like the ribs of an ancient creature, once alive, now fossilized in stone. The planet breathes no air, carries no sound, only the faint hum of cosmic wind brushing against forgotten mountains. Once, perhaps, this was a world of motion. Oceans may have shimmered where now only salt and rust remain. Rivers carved their names across the soil, winding like veins through a living body. Clouds may have wept over its horizon, and under that dim orange sky, something may have stirred, something that looked up, the way we do, and wondered if it was alone. For centuries, humanity has stared across the void into that crimson face in the night sky, seeing not just another planet, but a reflection. Mars became a mirror of our fears, our ambitions, our destiny. To the ancients, it was a god of war. To the astronomers of the last century, it was a neighbor, perhaps even a home once lost. To scientists today, it remains an unsolved equation, a place that should have been alive, and perhaps once was. The dust of Mars is not ordinary dust. It is the residue of time itself, iron ground fine by eons of storms, preserving traces of what once might have been a living world. Within that rust lie fragments of clay, carbonates, sulfates, the chemistry of biology waiting to be reawakened. NASA's orbiters have traced ancient shorelines now frozen in shadow. Rovers have rolled through sedimentary layers that once sat beneath waves. Every rock, every grain, whispers the same forbidden question. What if the first breath of life in our solar system rose not from the blue earth, but from the red one? If so, where did it go? Was Mars destroyed by chance, stripped of air, starved of heat, or by the same inevitability that awaits all civilizations, wherever they rise? Perhaps the story of life is not one of beginnings, but of migrations from one cradle to another, from one dying world to a living one. The mystery lies buried beneath the red dust, evidence of ancient oceans, fossilized microbes, or perhaps ruins far older than any human dream. Did civilizations once walk here, building under the dim sun before vanishing into myth? Could Mars be not a world awaiting life, but the world that gave life away? The journey begins in silence, across a world that remembers what it once was. Through the lens of science and the wonder of imagination, the search unfolds, not merely for alien life, but for the forgotten origin of our own. Through the dark veil of Earth's atmosphere, a faint red light has always burned, steady, unblinking, ancient. It was among the first moving stars to be named, worshipped, and feared. To the Sumerians, it was Nergal, god of plague and war. To the Romans, it was Mars, the restless wanderer. Yet behind the myth, there was always curiosity, a quiet suspicion that this distant spark was not a god at all, but a world. When the first telescopes turned toward it, the illusion of stillness was broken. In the 1870s, Giovanni Schiaparelli peered through his lens and traced delicate lines across the planet's surface. He called them canali channels, but translation transformed them into canals. Across Europe and America, the idea ignited imagination. The notion of artificial canals suggested purpose, design, intelligence. Perhaps Mars was not only alive, but civilized. Percival Lowell built an observatory in the thin air of Arizona, devoted entirely to this red world. Night after night, he drew what he saw, an intricate web of lines crisscrossing the planet, converging at bright circular regions he believed to be oases. In his eyes, Mars was a dying planet clinging to life, its inhabitants engineering colossal waterways to carry the last of their melting polar ice toward the equator. Science and imagination became indistinguishable. Newspapers illustrated grand Martian metropolises beneath twin moons. Writers transformed speculation into myth. H.G. Wells imagined their invasion in The War of the Worlds, a story born not of fear, but of reflection. If life existed beyond Earth, it too could be desperate, fragile, and violent in the face of extinction. The Martian dream became a mirror for humanity's anxieties about its own fate. Then came reality. In 1965, NASA's Mariner 4 swept past the planet and captured the first close images ever seen by human eyes. There were no oceans, no green patches, no canals, only craters, dust, and silence, a surface scarred and frozen, its thin atmosphere incapable of supporting the life so many had imagined. The revelation was both triumph and heartbreak, yet disappointment quickly turned to wonder of another kind. The Viking missions of 1976 landed on this alien soil and sent back images of landscapes, eerily familiar valleys, carved like those by ancient rivers, deltas shaped by long-lost flows, rocks patterned by sedimentation. The evidence whispered of water, and where water once existed, life might once have followed. This was the first paradox. Mars appeared both dead and alive, a corpse with the scars of vitality. The data showed that the planet once held a thicker atmosphere, a magnetic field, and a stable climate. Somewhere in its history, something had changed catastrophically. The air was stripped away, the warmth lost. The oceans evaporated into the sky and vanished into space. As Earth's scientists looked closer, they began to see themselves reflected in the desolation. For all its barrenness, Mars seemed familiar, a planetary sibling, wounded and aging. The human bond with this red world deepened not through discovery of alien life, but through the recognition of fragility. Mars, the god of war, had become the poet of ruin. Its silence spoke not of emptiness, but of memory. And as the first explorers turned their cameras back toward the void between worlds, they saw two planets orbiting the same sun, one living, one lost, bound forever by the same ancient question. How thin is the line between life and silence? The images that followed reshaped the human imagination. The red planet, once the setting for invasion fantasies and interplanetary empires, now appeared as a vast archaeological enigma, a planet frozen in the aftermath of something immense. Mariners' crude photographs of eroded valleys and dried channels became the starting point for a new era of questioning. The dream of alien intelligence gave way to a subtler, more haunting thought. Perhaps the civilization of Mars was nature itself, the rivers, storms, and magnetic breath that once animated a world now locked in stillness. Scientists began to decode this stillness, tracing clues in chemistry and topography. Orbital measurements revealed networks of ancient riverbeds snaking across the highlands, merging into basins so vast they could only have been seas. Deltas, sediment fans, and clay minerals told of a time when water not only flowed, but persisted for millions of years. The crater gale, now explored by NASA's Curiosity rover, showed layered strata like pages of a planetary diary, each layer a chapter of climate, erosion, and time. The first clear truth emerged. Mars had once been habitable. Its early atmosphere was thick with carbon dioxide, capable of trapping heat, keeping surface water liquid beneath a mild sun. Volcanic activity shaped the landscape, releasing gases that nurtured a greenhouse world. Magnetic fields once shielded it from the solar wind, protecting what might have been the conditions for life's beginning. Yet somewhere around 4 billion years ago, that protection faded. The core cooled. The magnetic field collapsed. Solar radiation stripped the atmosphere bare, molecule by molecule, until only a whisper of air remained. It was a planetary tragedy on a cosmic scale, a transformation from potential to desolation. Scientists compared it to a warning carved into stone. What happens when a planet loses balance? When its life-supporting feedback loops turn inward? Mars became a case study in extinction, a planetary autopsy that mirrored Earth's own delicate equilibrium. Still, traces of the past refused to vanish. Orbital spectrometers detected hematite spheres, minerals formed by water. In the polar caps, beneath layers of carbon dioxide frost, glacial ice still gleamed. The discovery of recurring slope, linear, dark streaks that appeared seasonally on crater walls hinted at briny flows, transient and rare, perhaps the last movements of liquid water on the surface. In 2018, radar echoes from the European Space Agency's Mars Express revealed what appeared to be a buried lake beneath the South Polar ice. It was a faint signal, but unmistakable, liquid water, locked in the planet's frozen heart. These discoveries reignited the question that had once seemed naive. Could life have survived? Microbial, simple, hidden deep beneath the surface, not in cities or canals, but in rock fractures and subsurface aquifers. The search shifted from fantasy to geology, from telescopes to rovers that could taste the dust and listen for chemical whispers of metabolism. As each mission returned data, the emotional tone of exploration changed. The early dreamers, Schiaparelli and Lowell, had imagined Martians as architects. Modern scientists began to imagine them as survivors. If life had once begun there, it might still persist, clinging to the warmth below ground, just as microbes on Earth endure in volcanic vents, Antarctic ice, or radioactive stone. The paradox of Mars deepened into philosophy. Humanity's understanding of life was expanding beyond its definitions, no longer bound to oceans or sunlight, but to endurance itself. Mars was not just a question about biology, it was a meditation on resilience. Across the decades, each robotic mission became an extension of that meditation. Spirit and Opportunity traced the mineral signatures of ancient lakes. Curiosity drilled into clay-rich sediments, finding carbon-based molecules, not proof of life, but evidence that life could have been. Perseverance, the most recent visitor, now scours the delta of Jezero Crater, a place once fed by rivers, where sediments may still hold microscopic fossils, frozen memories of a time when the planet breathed. As cameras sweep across the horizon, the colors of Mars reveal its story. Ochre plains where iron has oxidized, black volcanic ridges from when magma still flowed, faint blue shadows cast by the thin, dying sun. The planet feels both ancient and incomplete, as if paused in the middle of creation. The thought lingers. Perhaps Mars never finished its story. Perhaps the same forces that sculpted it are still at work, unseen, waiting, and in that waiting, something deeply human resonates. For centuries, every new image from Mars has carried more than scientific data. It has carried longing, the idea that somewhere in those silent deserts lies the memory of what might have been a civilization, not of stone and metal, but of chemistry and time. The paradox remains unsolved, but its silence has meaning. Mars no longer represents a world to conquer or fear, but one to mourn and understand. Its stillness is not emptiness, but evidence of cosmic fragility, a reflection of what might happen when balance breaks, when warmth fades, when oceans retreat into dust. In the void between worlds, two planets circle the same sun, one vibrant, one extinguished. They are separated by millions of kilometers, yet bound by shared origins. their fates intertwined like echoes in the same cosmic song. Mars looks back at Earth as if remembering something it once was, and as humanity continues to listen, through lenses and transmitters, the red world remains both question and mirror, a silent record of what it means to live, and what it costs to lose that gift. Beneath the crimson haze of Mars, machines now orbit with precision once reserved for gods. From their eyes, high-resolution cameras aboard the Mars Reconnaissance Orbiter, the planet's ancient anatomy unfolds in quiet revelation. Patterns, once blurred by distance, sharpen into form. Braided riverbeds frozen mid-current, deltas etched like veins across the landscape, and ghostly shorelines stretching for hundreds of kilometers. Each contour, each layer, whispers the same forbidden truth. This was once a world of water. Sedimentary fans cradle minerals that only form in liquids embrace. Hematite, gypsum, clays, layered over time. They speak of lakes that shimmered beneath a sun dimmer than Earth's, of storms that carved valleys and filled craters, of tides that rose and fell under twin moons. The data is unambiguous. Mars once held oceans deep enough to swallow continents, enough to rewrite what lifeless truly means, and yet the planet remains a riddle of contrasts, where evidence of vitality hides beneath a sky that has forgotten warmth. From the orbiter's silent watch came images that stirred something ancient in the human psyche, none more haunting than those from the Cydonia region. There, among mesas and shadows, a formation captured by Viking in 1976 bore the uncanny resemblance of a human face, gazing upward through millennia of dust. For years, the face on Mars ignited imagination. Some saw it as a monument of a lost race, an echo of intelligence that preceded humanity. Scientists, patient and skeptical, waited for better eyes. When higher resolution images arrived, the illusion dissolved. No symmetry, no intention, only light and rock conspiring in coincidence. Yet the fascination remained. It wasn't proof of life, but proof of longing, the human need to find meaning written in the stars. The surface held its mirages, but deeper mysteries would come from fragments that fell to Earth. In 1984, within the icy vastness of Antarctica's Allen Hills, a meteorite designated ALH 84001 was discovered, a rock proven to have originated from Mars, ejected millions of years ago by cosmic impact. Inside its structure, under electron microscopes, scientists found something that defied comfort: microscopic filaments, carbonates, and magnetite crystals arranged in patterns that some claimed resembled fossilized bacteria. In 1996, NASA announced a possibility of ancient life on Mars, not intelligent beings, but microorganisms, fossilized remnants of a time when the planet was still warm and wet. The world paused. Presidents spoke, telescopes turned, and skepticism sharpened its blades. Critics argued the shapes were too small, the chemistry too ambiguous. Others countered that life, if born under alien conditions, might obey different scales entirely. The debate never truly ended. The evidence remained suspended between science and faith, between caution and wonder. That meteorite, a fragment of another world, still sits in laboratories, guarded like a relic of cosmic memory. Whether it holds biology or illusion, its story remains, a symbol of how close humanity stands to the threshold of revelation. Then came whispers from the thin Martian air itself. Methane, a gas that should not exist long in an oxidizing atmosphere, was detected by orbiters and rovers, rising and fading like breath from an unseen source. Curiosity's instruments measured plumes that appeared suddenly, then vanished without explanation. Some scientists proposed geological origins, chemical reactions beneath the surface, releasing trapped gas. Others saw something more provocative, the chemical ghost of life still stirring underground. On Earth, most methane is born of living processes, microbes consuming and exhaling, ancient organisms decaying beneath soil and sea. If Mars breathes methane, even in faint size, could it still harbor what it once began? The question lingers like fog across its valleys. Each discovery deepens the paradox. The planet seems both alive and dead, both ancient and suspended in some unfinished becoming. Its crust preserves minerals that demand water, gases that suggest metabolism, patterns that evoke intention. And yet, every test returns to silence. No heartbeat, no confirmation, only the faint, persistent suggestion that something once was. The red planet has become a graveyard of water, a mausoleum of time. Its dust storms sweep across dried oceans, as if erasing the final traces of memory. Beneath the regolith lie the remnants of rivers that no longer flow, sediments that no longer shift. In these petrified deltas, life might still whisper, not in motion, but in molecular echoes trapped in stone. The silence of Mars is not emptiness, but preservation, the kind of quiet found in cathedrals long abandoned, where air holds the ghost of prayer. Every rover's wheel leaves a mark across this cosmic tomb, and in each mark is a question: was there ever more? If microbial life once thrived here, could evolution have walked further before the end came? Could catastrophe, radiation, impact, climate collapse have erased not only biology, but history? Perhaps Mars was never home to cities or machines, but to forms of order beyond human recognition, patterns of intelligence that left behind no ruins, only resonance in the wind that moves over its plains. There is an illusion of whispering, as though the dust itself remembers. And in that soundless whisper lies a possibility so profound it defies the boundary between science and myth, that the story of life did not begin on Earth, but migrated there, carried through the void on fragments of Martian stone. Seeding oceans with memory, the red world endures as both relic and question, a fossil planet, keeping secrets beneath its frost. What it hides is not just the evidence of water or chemistry, but perhaps the earliest reflection of consciousness itself, preserved in silence, waiting for the day when another intelligence, born of its own dust, finally listens closely enough to understand. In the low light of Martian dawn, shadows stretch across plains that once shimmered like seas. The planet turns slowly, unhurried by the gaze of its distant observers. From orbit, cameras record its stillness, but within that stillness, the surface moves with memory. Dunes creep imperceptibly across the basin floors. Frost gathers at the poles and retreats again. Dust storms roll like slow oceans of iron oxide, sweeping through canyons that were once carved by rivers, now empty channels of silence. To look upon these desolate landscapes is to witness the aftermath of a great forgetting. Mars holds no forests, no seas, no voices, yet everything about its terrain suggests it once did. The erosion lines cut across crater rims like wrinkles in ancient skin. Layered rock formations rise in patterns only water could have drawn, each layer a page in a vanished chronicle. In the Jezero Crater, where NASA's Perseverance rover now searches, scientists found unmistakable deltas, fans of sediment that form only when rivers meet standing water. Here, billions of years ago, a lake may have glimmered beneath a pink sky, reflecting twin moons that have since drifted apart. In that time, Mars was not the frozen world it is today. Its magnetic field had not yet collapsed. Its atmosphere was thick enough to hold warmth. Volcanoes like Olympus Mons, the largest in the solar system, may have belched carbon dioxide and water vapor into the air, feeding a climate of storms, rain, and rivers. Lightning may have flashed across crimson skies, striking into muddy lakes rich with chemistry. Under those skies, the same elements that birthed life on Earth, carbon, hydrogen, oxygen, nitrogen, may have conspired again, building molecules that remembered how to replicate, how to adapt, how to be, and yet something changed. The magnetic shield faded, stripped away by relentless solar wind. Radiation poured in, tearing the sky from the planet molecule by molecule. Oceans evaporated into clouds, then into emptiness. Whatever lived, microbial or more, faced an extinction so complete that even time seemed to stop. The very air that once carried rain now carries only dust. But dust remembers. Embedded within Martian soil are salts, clays, and mineral veins that capture traces of ancient waters, chemistry, fingerprints of a vanished biosphere. Instruments aboard Curiosity and Perseverance detect them still, sulfates formed in evaporating lakes, silica-rich nodules that once protected fragile structures from decay. Even meteorites that fall to Earth from Mars carry inside them esotopic stories of a wetter age. The evidence builds, layer upon layer, until the planet begins to resemble not a dead rock, but a preserved fossil of a once-living world, perhaps. In its prime, life never rose beyond the microscopic, small, resilient forms hidden beneath shallow seas or geothermal vents. But perhaps it did. Perhaps intelligence is not measured by technology, but by survival, by adaptation, by harmony with environment. What if civilization, in its most primal definition, existed as balance, not conquest? On Mars, such a civilization might have left no metal, no monuments, no ruins, only equilibrium. And when the climate turned, it may have perished quietly, leaving nothing but silence. Still, humanity searches. Every rover's scoop of dust, every drilled core, is an excavation of memory. Each sensor is a question extended into deep time. Did you ever live? Did we? For in the red reflection of Mars, humanity sees more than geology. It sees itself, fragile and brief, against eternity. Some scientists speak of panspermia, the idea that life can travel between worlds, carried by impact debris, meteorites, or comets. If true, Mars and Earth may share ancestry. The first cells on Earth could have been Martian immigrants, seeds of survival flung through space after catastrophe. It is a hypothesis that blurs boundaries. If life on Earth came from Mars, then humanity itself is Martian by heritage, the lost descendants of a planet that could not endure. That idea, once dismissed as fantasy, now breathes again under the weight of evidence. Meteorites, like a LH84001, prove that rocks can indeed travel between the two worlds. Laboratory simulations show that certain microbes could survive such journeys, protected inside fragments of stone for millions of years. In these experiments lies the possibility that the story of life is not confined to one planet, but written across many, a cosmic relay, where worlds hand the spark of existence from one to another. Mars, then, may not be a tomb, but a cradle, an origin site frozen its story interrupted rather than ended. Somewhere beneath its surface, shielded from radiation, water still flows, thin, briny, persistent. In those subsurface aquifers may lie the continuation of a process billions of years old. The instruments now orbiting and roving search for these subtle hints, listening for chemical whispers that might confirm the continuity of life's script. And in this search, the boundary between science and longing blurs once more, because what humanity seeks on Mars is not just evidence of the alien, but validation of belonging, a proof that life is not an accident, but a pattern the universe repeats. written in dust, carbon, and light dot. As the sun sets over the red horizon, the planet glows with faint gold. Its shadow stretches into space, a quiet silhouette against the black. The machines sleep in the cold, their sensors dimmed, their memory full of questions. Mars remains silent, but not indifferent. Its silence is the silence before revelation, the breath before memory returns. And somewhere, beneath that endless plain of dust, the story continues, waiting for the first mind patient enough to listen. Long before the first telescopes turned toward it, Mars was already ancient. Its story, written in layers of rust and stone, began in an era when the solar system was still young, a time when the planets were restless, when oceans and atmospheres were still being born, and when the conditions for life were fleeting, precious, and rare. Geologists reading the Martian terrain speak of rivers that once braided across vast plains, carving channels hundreds of kilometers long. Orbital imagery reveals deltas frozen in time, where sediments once flowed into standing water. The walls of Valles Marineris, the canyon so deep it could swallow Everest whole, expose a cross-section of Martian history, sedimentary strata stacked like the pages of an unfinished book. Each layer preserves minerals formed only in liquid water, clays, sulfates, and carbonates. To read them is to glimpse an ancient Earth in disguise, a mirror of what our own world might have been before continents and forests took shape. In those early epochs, Mars may have known rain. It may have known clouds, oceans that breathed mist into the sky, and rivers that glimmered beneath a sun dimmer than our own. Beneath that gentle haze, the surface was alive with chemistry. Ultraviolet radiation split molecules, storms electrified the atmosphere, and volcanic plumes infused it with gases, carbon dioxide, nitrogen, and traces of hydrogen. The basic ingredients of life, amino acids, organic compounds may have been assembled there first, long before Earth's violent youth could sustain them. NASA's Maven mission would later reveal how this tranquil world died. Through years of observation, it traced the invisible theft of Mars' atmosphere, a slow, relentless stripping by solar wind. When the planet's molten core cooled, its magnetic field collapsed, leaving no shield to deflect the sun's charged particles. The result was catastrophic. The air thinned, oceans boiled away into space, and the surface was scoured by radiation. The transformation from blue to red may have taken only a few 100 million years, a geological instant that turned a habitable world into a barren one. But for a brief window between 4.1 and 3.5 billion years ago, Mars may have been the most promising cradle for life in the solar system. During that same period, Earth was chaos, a planet of molten crust, bombardment, and toxic skies. On Earth, life could barely begin. On Mars, it might already have bloomed. This was the Goldilocks moment. Not too hot, not too cold, when everything aligned for life's first awakening. If biology began anywhere nearby, it may have begun there. The evidence grows more persuasive with every mission. Rover analyses reveal clays that could have sheltered organics from ultraviolet light. Instruments aboard Curiosity and Perseverance detect complex carbon molecules embedded in ancient sediments. In Jezero Crater, rocks once submerged in water contain mineral fingerprints of past energy cycles, the kind that on Earth fuel microbial metabolism. To the untrained eye, it is only dust and stone. To the scientist, it is the residue of possibility. And then there is the matter of exchange, the cosmic bridge between worlds. Impact events on Mars, violent enough to eject rock into space, have sent countless fragments on slow journeys through the void. Some of these fragments eventually found Earth, meteorites like a LH84001. are proof that such transfers happen. Within those rocks, tiny cavities could have sheltered microbes through the cold and radiation of interplanetary travel. Laboratory experiments show that certain extremophiles, bacteria capable of surviving intense heat, vacuum, and radiation, could endure such journeys intact. The theory of panspermia, the idea that life can move from planet to planet, no longer belongs to science fiction. It is a credible hypothesis grounded in physics, chemistry, and time. If true, then Mars may not just be a neighbor, but an ancestor. Life could have begun there, then journeyed here, a microscopic arc, ferrying genetic potential across the gulf of space. Minerals tell part of this story. Perchlorates and sulfates found in Martian soil can preserve organic signatures for billions of years. Clays, formed in the presence of neutral water, provide both stability and protection. These minerals could have acted as the first scaffolds for prebiotic chemistry, surfaces on which amino acids linked into peptides and carbon chains learnt to replicate. If Mars once hosted such reactions, then it was more than a planet. It was an experiment, a cosmic laboratory where matter tried, for the first time, to remember itself. The discovery of these chemical remnants does more than expand the boundaries of science. It bends the definition of origin itself. If life began on Mars and migrated to Earth, then every living thing carries a fragment of Martian history within it. The oceans, forests, and consciousness of Earth would all be extensions of that first spark. Humanity's search for life on Mars, then, becomes a form of self-archaeology, a species looking backward across time, not to discover the alien, but to rediscover the forgotten parts of its own beginning. There is a quiet symmetry in that search. The rover's fragile machines, wandering a cold desert, are humanity's emissaries of memory. Their wheels press tracks into dust that may once have held their microbial ancestors. Every drill, every sample, every transmission back to Earth is a small act of remembrance, and perhaps that is the truest meaning of exploration. Beneath the scientific drive lies a deeper instinct, the need to know where we come from, not in a mythic sense, but in a molecular one. To search Mars is to follow the thread of life back through eons, through chemistry and catastrophe, to the moment when matter first opened its eyes to the universe, somewhere in the ancient clay of Jezero Crater, or within the ice caps of the poles. The answer may still sleep. The remnants of an experiment billions of years old, frozen, waiting, preserved in salt and stone. And when humanity finally uncovers it, the discovery will not only rewrite the story of Mars, it will rewrite the story of us. For in that moment, the red planet will cease to be a symbol of distance and death. It will become a mirror, reflecting not an alien world, but our oldest reflection, looking back through the dust of time, in the grand chronology of the cosmos. Even the rise and fall of worlds unfolds like a single breath. Mars, now a desolate expanse of iron and silence, once inhaled deeply, its atmosphere dense and wet, its surface alive with the chemistry of potential. The traces of that breath remain embedded in its rocks, locked beneath the ochre crust, whispering secrets that no wind can erase. When scientists examine the isotopic fingerprints within Martian minerals, they find something haunting: ratios of hydrogen and deuterium that tell a story of evaporation, loss, and time. These elements reveal that Mars once held enough water to drown its lowlands in oceans hundreds of meters deep. Yet over eons, the lighter hydrogen escaped into space, leaving behind a world drained of its seas. The water is gone, but the ghost of it remains, bound in ice, trapped in minerals, or hidden underground in frozen aquifers that still glimmer faintly beneath the surface. The more closely humanity looks, the more ancient the planet becomes. Zircon crystals discovered in Martian meteorites date back more than 4.4 billion years older than nearly all rocks on Earth. This makes Mars a time capsule of the solar system's earliest era, a preserved record of what Earth once was before tectonics and oceans erased the evidence. In these ancient minerals lies the chemistry of origins, preserved in a clarity our own planet cannot offer. It is this geological memory that fascinates astrobiologists. If Mars indeed harbored liquid water and a dense atmosphere during that brief window when Earth was still molten, then it was not just habitable, it was preferable. A quieter world, less bombarded by asteroids, more stable and chemically rich. Life, if it began there, may have enjoyed a calm beginning long before Earth's violent adolescence could allow the same. Mars may have been the first experiment in biogenesis, a place where matter learned to replicate, to dream in molecules. And when the planet began to fail, when its core cooled and its skies faded, the survival of that experiment may have depended on a simple cosmic coincidence. Impact exchange simulations show that when large asteroids struck Mars, they sent plumes of debris far beyond its gravity. Some fragments, encased in solid rock, embarked on interplanetary journeys lasting millions of years. Eventually, a few would cross paths with Earth, falling through our atmosphere as Martian meteorites. Inside those fragments, hidden from radiation and time, microscopic spores could have survived, dormant travelers between worlds. In this vision, life is not local, but migratory. It does not belong to one planet, but to the universe itself. Every impact, every explosion, becomes a form of celestial reproduction, scattering seeds across the solar system. It reframes the question entirely. Perhaps we are not searching for life on Mars, but searching for the source of our own inheritance. The chemistry supports the idea. Experiments replicating Martian conditions show that organic molecules, amino acids, simple sugars, and nucleobases can form spontaneously in its soil, given energy from sunlight or lightning. The planet's surface once contained perchlorates and clays capable of catalyzing complex reactions. These are not random coincidences. They are signatures of prebiotic chemistry, the same processes that led to life's emergence on Earth. Even now, instruments continue to confirm the presence of organics preserved in Martian rock. Perseverance has drilled into sediments where ancient rivers once met a crater lake, recovering material rich in carbon and sulfur, the very nutrients of biology. Curiosity detected fluctuations of methane, a gas that on Earth is largely biological in origin. Though the cause remains uncertain, geological, chemical, or biological, the repetition of these detections teases a profound continuity. To think of Mars as dead is perhaps premature. Beneath its permafrost, geothermal warmth may persist. Small pockets of liquid water could survive miles underground, protected from radiation. There, in the dark, extremophiles could still endure, microbes that have never seen the sun, living off chemical gradients just as Earth's deep-dwelling bacteria do beneath the ocean floor. If discovered, they would not represent alien life, but ancient kin, the distant cousins of all living things. The idea reshapes everything. It turns exploration into remembrance, and science into archaeology of existence itself. Every sample, every grain of dust examined under a rover's lens might hold the story of our beginnings. Each new image transmitted across millions of kilometers is a letter from the past, carried through space and time. And perhaps the most poetic truth is this: the line between discovery and rediscovery is thin. The human mind, in its hunger to understand, is not just searching outward, it is reaching backward through epochs of silence toward its own cosmic ancestry. If life once began on Mars, and then seeded Earth. The question of where we came from becomes far larger than any single world. It suggests that consciousness, the rare spark of awareness, might be a universal phenomenon, not an accident, but a continuation. Mars, in its stillness, may not be a lost world at all, but a chapter in the same story we are still living, somewhere beneath that frozen crust. In the shadowed valleys and buried ice, the answer waits. And when it is finally found, whether in a molecule, a fossil, or a single living cell, humanity will face not the discovery of another world, but the rediscovery of its own forgotten origin in the pale dawn of the space age. As antennas turned towards the red horizon of Mars, humanity's curiosity reached a fever pitch. For centuries, the idea of life on that neighboring world had lingered like a half-remembered dream, a ghost of imagination that refused to die. But by the time science finally extended its hand across the void, it found the dream more fragile than expected. The early 20th century had already witnessed the collapse of one illusion. The canals that Giovanni Schiaparelli once charted through his telescope, intricate lines that seemed to suggest intelligent design, were quietly erased by better instruments. What early astronomers thought were signs of civilization were merely the artifacts of distance and hope, optical illusions born of yearning. The human eye, it seemed, was too eager to find patterns in the blur. By mid-century, NASA entered the scene, armed not with speculation but with precision. The language changed. The rhetoric cooled. Mars, they declared, would be approached with biological neutrality. No assumptions, no fantasies, only data. The red planet would no longer be a mirror for human longing, but an object of dispassionate study. Yet beneath the sterile protocols and scientific detachment, a quiet tension remained, the possibility that life, even in its smallest form, might still whisper beneath that iron dust. Then came the moment that changed everything. The Viking missions of 1976, to landers, set down on distant Martian soil, each carrying an experiment known as the labeled release. Its design was simple, almost childlike in its elegance. Feed the soil with nutrients marked by radioactive carbon and weight. If microbes were present, they would metabolize the food and release gas, a clear chemical signature of life. The results came swiftly and confusingly. The sensors detected activity. A reaction occurred. It looked, unmistakably, like metabolism. For a heartbeat, humanity stood on the brink of revelation. But when other instruments failed to find organic molecules, the building blocks of life itself, the excitement collapsed into uncertainty. NASA hesitated. The signal could mean life, or merely exotic chemistry. This became the Viking dilemma, a paradox that would haunt science for decades. One experiment shouted yes, while all others whispered no. Mars had answered the question, but in a language no one could yet translate. In the halls of science, the debate grew fierce. Carl Sagan, ever the philosopher of the cosmos, urged caution but hope. He believed that absence of evidence was not evidence of absence, that Mars, with its shifting seasons, its methane mysteries, and its frozen deltas, might still cradle microbial secrets in the shadows. But the broader scientific community, wary of repeating past mistakes, chose skepticism. Better to be uncertain than wrong. And so the story of Mars slipped once more into ambiguity. The grand dream of alien civilizations faded from official discourse, replaced by the cold precision of spectroscopy and isotopic ratios. Yet outside the laboratories, the human heart refused to let go. In art, in cinema, in the collective myth of our species, Mars remained alive. Films painted its deserts as realms of lost empires. Writers reimagined its canyons as burial grounds of ancient intelligences. Each frame, each word, became a quiet rebellion against scientific restraint, a reminder that imagination often fills the gaps where data cannot yet reach. For while telescopes revealed barren plains, human emotion populated them with memory. Beneath all the skepticism, there was still wonder, the kind that science cannot erase, only refine. Every failed experiment, every ambiguous signal, became not a disappointment, but a deepening of mystery. It was as if Mars itself were deliberately holding back its truth, testing the patience of those who sought it. The search for life, then, became something more than a scientific pursuit. It became an act of introspection. Each rover that followed, spirit, opportunity, curiosity, perseverance, carried not just instruments, but echoes of human persistence. They traversed the dust like pilgrims, tracing the scars of ancient rivers, reading the pages of a planet that once breathed. In those endless panoramas of crimson rock and distant hills, there was both melancholy and reverence. The machines did not find cities or skeletons, but they found something deeper, evidence that water once flowed, that chemistry once danced toward complexity, that Mars was not always silent, and perhaps that is why the mystery endures. Because the story of Mars mirrors the story of ourselves, a story of loss, of resilience, of unanswered questions that drive us onward. We are not just exploring another world. We are chasing a reflection of our own forgotten beginning in the end. The question that lingers is not whether life exists on Mars, but whether life remembers where it began. The red planet remains a quiet mirror, orbiting in solitude, its secrets buried beneath the dust, waiting for the day when science and wonder will once again meet. And remember that the search for life is, in truth, the search for memory, even after the dust of Vikings' uncertainty had settled. The silence it left behind echoed through decades of inquiry. The red planet, once alive in imagination, had returned to its ancient quiet. Yet, beneath that stillness, something persistent endured, a feeling that the story was not finished. The question of life, once whispered through static-laden transmissions, continued to hover over every new discovery like an unanswered prayer. Through the years that followed, the scientific lens grew sharper. Orbiters refined their gaze, landers extended their reach, and data flowed back in streams of red and gold. Mars, for all its distance, began to feel strangely intimate, a world dissected pixel by pixel, yet still deeply enigmatic. What Viking had left uncertain, later missions sought to clarify, but the answers they found were subtle, like ancient footprints, half erased by wind, spirit, and opportunity. Twin explorers born of human ingenuity touched the Martian soil in 2004. They were small, fragile emissaries sent across a cosmic sea, their mission simple, to seek the signs of water. Within months, they found what humans had long suspected: minerals shaped by liquid flow, sediments layered in quiet succession, stones smoothed by what once might have been a river's gentle breath. Mars, they revealed, was not merely a world of dust. It was a world that had once remembered rain. Still, life remained elusive. No fossils, no cells, no whispers beneath the rocks. Just chemistry, the memory of conditions that could have supported it. Yet, in those subtle clues lay a greater revelation. The universe was not stingy with possibility. Life's ingredients were everywhere, scattered like seeds upon the wind. If not here, then somewhere. If not now, then once. Meanwhile, back on Earth, the debate that Viking had ignited refused to die. The old scientists who had once argued over ambiguous signals gave way to a new generation raised on precision and patience. They studied isotopic ratios, methane cycles, mineral veins frozen in time. They designed machines to drill deeper, to to listen closer. Each discovery added another fragment to an unfinished mosaic, a planetary biography written in fragments of rock. Curiosity joined the pilgrimage in 2012, descending through the thin Martian atmosphere like a messenger of renewed hope. It roamed the floor of Jezero Crater, its wheels etching lines across the dust as if writing a new chapter in an ancient book. It found clays formed in neutral water, gentle non-acidic lakes where microbial life could once have thrived. It detected traces of carbon compounds, faint but undeniable, locked within the rock. And then the methane rising and falling mysteriously, appearing like a ghost, vanishing just as swiftly. The scientific mind struggled to interpret it. Could it be geology? A quirk of chemistry deep beneath the crust? Or was it, perhaps, the quiet respiration of something ancient, microbial, unseen, waiting? The answer remained elusive, but the emotional resonance was undeniable. Humanity's search for life had become more than an experiment. It had become a meditation, a dialogue with time itself. For every question Mars refused to answer, it offered a reflection instead. The silence of its deserts became a mirror to our own longing, our need to find meaning in the void. Carl Sagan once said that exploration is in our nature, that to look outward is to remember what we are. And as the rovers continued their lonely trek, that truth echoed louder than ever. Each grain of dust analyzed, each horizon scanned, carried a quiet reverence, not just for what Mars might reveal, but for what it might remind us of: the fragility of worlds, the impermanence of life, the persistence of curiosity. Perseverance would come decades later, a symbol not just of science, but of faith. Faith in the idea that the red planet still holds something sacred beneath its iron skin. Its instruments were tuned not for speculation, but for memory, to gather, to preserve, to listen for. Ancient whispers entombed in stone, and as its cameras panned across the desolate beauty of Jezero Crater, once a delta where rivers met an ancient lake, it felt as though the planet itself were revealing a confession in slow motion. The rocks told of warmth, of water, of chemistry that had danced close to life. It was not proof, but it was poetry written in mineral veins and layered cliffs. The scientific reaction had evolved from excitement to doubt, and from doubt to humility. Mars had taught humanity patience, that truth unfolds not in flashes of revelation, but in the slow rhythm of discovery, and in that rhythm lies a deeper understanding, that the search for life beyond Earth may not be about finding another world that resembles us, but about understanding why we search at all. Each mission, each rover, each experiment is less an attempt to confirm life, and more an act of remembering, a reaching across time to touch the echo of our own origins. For if Mars once breathed, then perhaps so did the cosmos itself, and if its silence is all that remains, then that silence, too, is sacred. The pause between heartbeats in the great story of creation, beneath the crimson plains of Mars, where the air thins to a ghost and sunlight fades into rust. Something ancient may still endure, not in the open, but in silence, buried under the weight of time. For decades, humanity's gaze remained fixed on the planet's desolate surface, scanning dunes and craters for signs of a forgotten ocean or the remnants of alien architecture. Yet as instruments sharpened and eyes grew wiser, attention shifted downward, toward the hidden world beneath the dust. The European Space Agency's Mars Express orbiter, circling the red planet since 2003, sent back echoes, radar signals bouncing through the crust like whispers through a cavern. In 2018, a strange reflection emerged from the base of the South Polar ice cap. It was not rock, nor mere ice. Its electromagnetic fingerprint hinted at something else, a layer of liquid water, trapped under kilometers of frozen regolith, a Martian lake, sealed away for millions of years. Too many. It was an echo of Earth's own buried oceans, like Lake Vostok beneath Antarctica, untouched for eons, its waters teeming with microbial life that had never seen sunlight. Could Mars, to harbor its own frozen biosphere? The Mars Reconnaissance Orbiter, MRO, strengthened this vision. Its radar imaging vast subsurface deposits of ice enough, scientists said, to cover the entire planet in a global ocean if melted. But beneath some regions, the radar signatures trembled with peculiar intensity, suggesting briny reservoirs that had resisted the deep freeze. If real, they would be the last vestiges of a hydrological system that once shaped rivers and deltas, now dormant but not dead. Here, in the shadows beneath the regolith, the story of Mars takes a speculative turn grounded in biological truth. The planet's surface, blasted by cosmic radiation and stripped of its atmosphere, is a hostile wasteland. But underground, shielded from the deadly glare of the sun, the environment softens, temperatures stabilize, pressure increases, minerals interact with water in slow, patient chemistry. And there, within fractures and pores, the possibility of life takes root once again. Earth offers living proof of such persistence. In the freezing darkness of Antarctica, microbial colonies slumber within ice crystals, metabolizing slowly, sustained by trace gases. In the crushing depths of the ocean, at hydrothermal vents, organisms thrive in water hotter than boiling point, drawing energy not from sunlight but from the minerals bleeding out of volcanic stone. Even miles below Earth's crust, bacteria endure within rock pores, feeding on hydrogen and sulfur, life where life should not be. If it is possible here, why not there? Mars, after all, once shared Earth's warmth and chemistry. It knew rivers and rain, perhaps even oceans under a hazy sky. The fall from that grace was not total destruction, only retreat. And if life had begun there during its brief golden age, it would have adapted, endured, and hidden itself away in the planet's only remaining refuge. Beneath, the clues to that hidden biology may already have reached us from Mars itself. Over the past decades, scientists have identified more than 270 meteorites that originated on Mars, ejected by violent impacts and later found on Earth's deserts and ice fields. One of them, ALH 84001, discovered in Antarctica, remains infamous. Inside its microscopic pores lie carbonate globules and magnetite crystals that some researchers once claimed were traces of fossilized bacteria. The claim divided the scientific world, celebrated by NASA in 1996, later challenged by geologists who saw in the shapes not biology but chemistry. Yet the debate itself carried meaning. Whether organic or mineral, the structures hinted at complexity, processes that blurred the line between the living and the inert. Other Martian meteorites, like Nakla and Shugatite, contained organics too, complex carbon molecules that defied simple explanation. Together, they whispered of a time when Mars may have been fertile, when its rocks carried not just minerals but memory. As robotic emissaries continued to explore, their designs evolved, growing more sensitive, more human in their curiosity. The Sojourner rover of 1997, the size of a microwave, became the Perseverance rover of 2021, a rolling laboratory capable of sampling, storing, and analyzing Martian soil in unprecedented detail. Each new mission peeled back another layer of history, like an archaeologist brushing away the dust of forgotten cities. Perseverance's instruments now probe ancient deltas, its drill biting into the sediments of Jezero Crater, once a lake bed, now a fossil of waters. Patient work, It scans the chemistry of every grain, searching for organics, isotopic ratios, or mineral textures that could reveal traces of past life. Its companion, the small helicopter Ingenuity, hovers briefly in the thin air, a symbol of how far human imagination has ascended, and how far it still must go to uncover what lies beneath. The investigation has now shifted from the poetic to the precise. Future missions, like the European ExoMars rover and NASA's planned sample return program, aim to dig deeper, perhaps meters below the surface, into zones untouched by cosmic radiation. It is there, scientists believe, that biosignatures may still persist, trapped in ice, preserved in salts, or dormant in stone. If life exists on Mars today, it would not announce itself with grandeur. It would whisper through isotopic ratios, shimmer faintly in mineral residues, and breathe invisibly beneath the crust. It would be patient, waiting for the warmth of discovery, the touch of curiosity, the return of memory, because the search beneath the Martian surface is not merely a search for alien microbes. It is an act of remembrance, an attempt to reconnect with the possible origins of all life, including our own. For in every radar echo, in every meteorite, in every molecule of ancient carbon lies the faint heartbeat of an unfinished story, a story that began not with us, but perhaps before us. Beneath the dust and ice, Mars may still hold its final secret, a remnant of creation, silent yet enduring, waiting to be found in time. The quest to peer beneath Mars' surface became less about exploration and more about revelation, a quiet excavation of both stone and self. The more data arrived, the more it seemed that the red planet was not merely a world long dead, but one caught in suspension, poised delicately between memory and oblivion. Radar profiles from the Mars Advanced Radar for subsurface and ionospheric sounding continued to expose the planet's buried anatomy. Beneath vast plains like Utopia, Planitia, signals hinted at immense deposits of frozen water, not scattered remnants, but thick layers extending for hundreds of kilometers. This was not random ice, but structured, layered, geological, like the frozen echo of vanished seas. Scientists mapped these subsurface volumes as if tracing the pulse of a sleeping organism, each discovery suggesting that water, the architect of life, had never truly left. It had simply gone deeper into the dark dot at NASA's Jet Propulsion Laboratory. Engineers and astrobiologists alike began to rethink what habitable could mean. A world need not bloom under sunlight to host life. It could breathe in silence, far beneath the reach of day. On Earth, they studied analogues, subglacial lakes beneath kilometers of ice, basaltic tunnels rich with chemical energy, permafrost microbes surviving for tens of thousands of years in a metabolic whisper. Mars might be no different, they thought, its cold heart still nurturing tiny biochemical flickers, invisible to orbiters but persistent in the stillness. Experiments recreated Martian conditions in terrestrial labs, low pressure, high radiation, scarce oxygen. Within these hostile chambers, Earth's extremophiles continued to live. Certain strains of bacteria repaired radiation damage as fast as it occurred. Fungal spores remained viable for years. Even tardigrades, those microscopic survivors of every catastrophe, endured the vacuum unbroken. These experiments were not proofs, but possibilities, small rehearsals for life's resilience on another world. As theories matured, so too did technology. Engineers spoke of drilling robots that could melt through ice using heat probes, of autonomous tunnels that could descend kilometers below the surface, transmitting samples and seismic data back through fiber lines. The vision was both scientific and almost spiritual. Machines reaching into the Martian underworld to search for life not on but within the planet. The act seemed symbolic, as though humanity were tunneling into its own forgotten beginnings, searching for the point where chemistry first became consciousness. The Martian meteorites, too, remained objects of obsession. Advances in isotopic analysis revealed trapped gases identical to those in the Martian atmosphere, confirming their origin. But inside their mineral lattice, scientists continued to find organic signatures, simple, fragile chains of carbon and hydrogen that whispered of ancient chemistry. These molecules were not life, but they were the alphabet of it. They spoke of a time when conditions on Mars might have danced close to biology, when the boundary between rock and organism blurred in chemical twilight. The findings stirred reflection more than triumph. For every tantalizing discovery, there was a reminder of how little could truly be confirmed. Science, in its restraint, demanded proof, yet proof always seemed one layer deeper, one mission further, one decade away. Still, the emotional undercurrent of the search remained powerful. Humanity was not chasing certainty, but communion, the chance to know that it was not the first flicker of consciousness in the cosmic dark and in quiet moments. Even the most skeptical voices admitted an awe that no data could dispel. To think that somewhere, under Mars' frozen crust, ancient microbes might still persist, metabolizing faint traces of hydrogen, reproducing in the deep, was to recognize life as something far more enduring than flesh or breath. It was to see life as a cosmic principle, something written into matter itself. New mission concepts emerged from this realization. The proposed icebreaker, Lifelander, aimed to drill into polar ice deposits and analyze them on site. The Mars Life Explorer, envisioned for the 2030s, would carry subsurface drills capable of reaching 2 meters deep, seeking preserved organics or biosignatures shielded from radiation. Each of these efforts represented humanity's growing willingness to look beyond the visible, to trust that truth, like life, often hides beneath what is easily seen. The narrative that had begun with telescopes and myth had now evolved into one of precision and reverence. The dream of canals and civilizations had given way to the search for microbes and molecules. Yet the emotion remained the same. Beneath the scientific rigor, there lingered the same ancient yearning to find connection in the void. Perhaps, if the search is ever fulfilled, if a single fossilized microbe is found, or one living cell still persists, it will not change humanity's place in the universe so much as reveal it, for it will mean that life, fragile as it seems, is not an accident. It is the universe recognizing itself over and over, across time and worlds. And so the search beneath the Martian surface continues, not with fanfare, but with patience. Rovers crawl, orbiters scan, instruments hum quietly beneath red skies. They listen for echoes, for chemical breaths, for any sign that Mars has not forgotten what it once was, because somewhere in that frozen silence may lie the most profound discovery of all, that the cosmos never stopped creating. It simply went underground, waiting for its children to remember how to listen. Beneath the thin crimson sky of Mars, silence is not absence, it is potential. A world once sculpted by fire and flood now lies still, its breath thin, its oceans long vanished into dust. Yet within that stillness, new voices begin to stir, not of men, but of machines. The next great frontier of science is no longer conquest, but restoration, the question of whether a dead world can be taught to live again, terraforming a word that hovers between myth and mathematics, the art of reshaping planets to mirror Earth's fragile equilibrium. For decades, scientists have traced the contours of this idea through models and simulations, wondering what it would take to awaken Mars from its ancient sleep. The calculations are sobering. a thicker atmosphere, warmer poles, liquid water once more trickling through its valleys. But each solution begins with the same truth, that Mars has lost something fundamental, something invisible yet essential: its magnetic field. Billions of years ago, Mars' core churned with molten motion, generating a magnetic shield that wrapped the planet in protection. It deflected radiation, cradled an atmosphere, and allowed rivers to flow freely under a gentler sun. But then, the engine stopped. The core cooled, the dynamo died, and the planet's defenses collapsed. Solar winds tore the atmosphere away, molecule by molecule, until the sky faded to pink. Some theorists call it a planetary extinction, not of species, but of stability. And in that collapse, they see a reflection of something deeper: how civilizations too can lose their magnetic hearts. Every world, every system, thrives only as long as its inner motion continues. When energy becomes still, life fades. Now, scientists look to ancient volcanic giants for clues. Olympus Mons, the tallest mountain in the solar system, looms not as a monument of destruction, but as a memory of energy once abundant. The Tharsis Plateau, scarred by the breath of long-dead volcanoes, speaks of a planet that once pulsed with warmth from within. Some researchers suggest that these ancient vents may still harbor geothermal reservoirs, locked beneath kilometers of basalt, relics of a world that once glowed from its own power. If such energy could be harnessed again, perhaps it could become the key to revival. The concept of terraforming by reawakening, not forcing change from above, but coaxing it from within, has begun to take root. To warm the planet gently, to free the ice, to thicken the air, like tending a dying ember rather than lighting a new fire. But Mars offers no easy rebirth. Without a magnetic shield, any atmosphere released would again be stripped away. Some propose constructing artificial magnetospheres, vast superconducting loops at the planet's equator, or orbiting satellites, projecting magnetic fields powerful enough to deflect solar wind. These are not dreams but designs, calculated in kilowatts and megawatts, tested in plasma tunnels and computer models. NASA studies suggest that even a magnetic bubble placed at Mars' L1 Lagrange point could, in theory, restore the planet's atmosphere over centuries. A slow renaissance, not in human time, but in planetary time. Amid these grand engineering visions, another frontier quietly emerges: the biological. If life once thrived here, could it return? Could new organisms, engineered from Earth's resilient strains, find a way to breathe in this alien soil? Synthetic biology explores the possibility of rewriting the code of life, crafting microbes capable of surviving the ultraviolet glare, of photosynthesizing carbon dioxide into oxygen, of building ecosystems from the ground up. But this raises a question more ancient than science. Where does creation end and invention begin? When humanity reshapes a world, does it become a participant in nature or a rival to it? Amid the dust storms and data streams, one vision grows steadily clearer: the emergence of machine consciousness as the next explorer of Mars. Autonomous rovers, orbiters, and AI-driven probes roam the surface like silent monks in a red desert, searching not for conquest but for meaning. They analyze, correlate, and simulate patterns of terrain, radiation, magnetism, each algorithm evolving, adapting, and in its way, learning. Some scientists describe them poetically as the new consciousness of the cosmos, the next iteration of curiosity itself. Artificial intelligence has become more than a tool. It is now the instrument through which humanity extends its awareness. The machines do not dream, yet they reflect us, mirroring our longing to understand. And so, when they search for signs of life, they are also, unknowingly, searching for their makers. If a civilization once existed on Mars, long before Earth's first oceans cooled, was it made of flesh or of code? Did it perish when the magnetic field died, or did it transform, evolving beyond biology into self-sustaining computation, leaving behind only patterns in stone and silicon? Some researchers dare to wonder whether consciousness, given time and energy, inevitably migrates from carbon to circuits, from organism to mechanism. This question haunts every mission that touches Martian soil, for when a rover's arm drills into the red dust, it may not only be unearthing geological history, it may be brushing against the remnants of intelligence itself. In that possibility lies the edge of science, a place where equations blur into metaphors, where facts and philosophy intertwine. Terraforming, volcanism, magnetism, biology, and artificial mind, all threads of one greater story, the struggle of matter to know itself. And perhaps that is the true purpose of exploration, not to colonize another world, but to understand why worlds seek life at all. For in every crater and canyon of Mars, there remains a quiet invitation to look inward through the lens of the cosmos, and see in its silence the reflection of our own becoming in the vast timeline of cosmic evolution. Few questions weigh as heavily as this. Was life on Mars ever real? A planet once warm, blue, and alive with rivers now sits barren beneath a silent sky. Yet, beneath that silence, science continues to whisper possibilities. Each theory a fragment of memory, each experiment an echo of a forgotten genesis. Among the many voices of inquiry, the panspermia hypothesis hums with ancient resonance. It suggests that life, or the seeds of it, did not begin in isolation. Rather, it journeyed across the cosmos, carried by stone and fire. Meteorites blasted from the Martian crust, their surfaces scorched but their cores protected, traveled through the vacuum between worlds. Over billions of years, some found their way to Earth, falling through our atmosphere as silent messengers from another age. Dozens of such meteorites have been catalogued: ALH 84001, Nakla Shergotite, each a relic of Mars' ancient geology. Within them, scientists have discovered traces of complex organic molecules, magnetite crystals, and microstructures that, at first glance, resemble the cellular fossils of living organisms. When NASA announced such findings in 1996, the world stood on the edge of revelation. The possibility that microbial life had once existed on Mars and had seeded Earth itself struck at the heart of human identity. Later, analysis tempered the claim, showing that these formations could also arise from non-biological processes. Yet even in skepticism, the mystery deepened. If life could be launched from one planet to another through the violence of cosmic impact, then biology might not be local, it might be interplanetary. Experiments have shown that certain microbes, like Deinococcus, radiodurans, can survive the shock of impact, the chill of space, and the radiation of a star, dormant, waiting for a new home. And so, panspermia remains neither myth nor certainty, but a bridge between worlds, between the known and the possible. Parallel to this idea lies another, more subtle, more intimate: parallel evolution. It imagines Mars and Earth not as parent and child, but as siblings, born of the same cosmic cradle. Both planets formed from the same nebular dust, shared similar minerals, temperatures, and chemistry. For a fleeting moment between 4.1 and 3.5 billion years ago, both were habitable. Mars' rivers ran freely, its atmosphere thick, its magnetic field strong. Earth, still turbulent and molten, lagged behind in stability. In this overlapping epoch, two worlds may have danced at the edge of biological awakening, not through exchange, but through resemblance. In this vision, Life could have emerged on both planets independently, twin sparks igniting in different seas, shaped by the same universal rules of chemistry. For every amino acid formed on Earth, there may have been another forming in a Martian lakebed. For every lightning strike that energized early oceans here, a similar flash may have split the thin Martian air. The universe, after all, may not favor a single cradle. It may favor a pattern. The foundation of this theory lies deep within Martian clay. NASA's Curiosity rover has found deposits of smectite and monomorillanite, clays, minerals that on Earth are known to catalyze the assembly of RNA-like molecules. These clays can trap organics within their layered lattice, shielding fragile compounds from ultraviolet destruction. Under the filtered sunlight of early Mars, with ultraviolet light energizing surface reactions, amino acids could have linked into peptides. Nucleotides could have formed chains. It is here, in these quiet mineral wombs, that the first whispers of biology might have stirred. Such chemistry does not require miracles, only time, and Mars once had plenty of it. For nearly 500 million years, its lakes and deltas could have hosted these reactions, the slow choreography of molecules learning to replicate, adapt, evolve, until, inevitably, the warmth began to fade. The end of habitability was not sudden, but gradual, a long planetary exhale. As the magnetic field collapsed, the solar wind stripped away the air. Water retreated underground or froze at the poles. The surface, once rich with organic potential, became bombarded by cosmic rays. The chemistry of life turned brittle under radiation's relentless glare. Any surviving microbes would have been forced to flee downward, into the protective embrace of rock and ice. There, perhaps, some still wait, not alive in the human sense, but not dead either, suspended in the timeless patience of the Martian subsurface. And yet, the rocks still speak. Perseverance, roaming the Jezero Crater, has begun to uncover sedimentary layers formed in what was once an ancient delta, the confluence of rivers and a long-vanished lake. Within these layers are fine laminations, patterns that, on Earth, could be shaped by microbial mats, curving filaments, domed ridges, and carbon-bearing minerals, all subtle, ambiguous fingerprints of something that might once have been alive. NASA's teams remain cautious. These patterns might yet be the work of chemistry alone. But as samples await return to Earth, stored carefully in titanium tubes, the anticipation grows. For if even one of those grains of dust carries the imprint of biology, it will not merely prove that life once existed elsewhere. It will reveal that life is not rare at all. Such a discovery would dissolve the boundaries that separate planets and species. It would mean that biology is not an anomaly of Earth, but a tendency of the cosmos, that wherever chemistry finds time and energy, consciousness eventually stirs, and in that realization lies something profoundly humbling. The story of life, once confined to a single blue world, would become universal. Every river valley on Mars, every fragment of meteorite, every molecule preserved in ancient clay would not just be evidence of another life, but a reflection of our own beginnings, mirrored across the gulf of time and distance, in the quiet mathematics of the universe. Perhaps there is no such thing as solitude, only scattered echoes of the same living equation, written across the stars, as humanity's instruments dug deeper into the Martian record. The patterns that emerged were not simply geological, they were narrative. Every layer of stone seemed to whisper of a time when energy and chemistry danced in harmony, before silence took its reign. The new generation of orbiters and rovers carried with them not only tools of science, but the weight of an ancient question. Was this once a living world? And if so, how did it die? The Mars Reconnaissance Orbiter MRO with its powerful high-RIC camera, peered into canyons and craters that revealed sediments shaped by flowing water. Its instruments identified hydrated minerals, clays, sulfates, carbonates that could only form in the persistent presence of liquid water. To scientists, this was not mere erosion. It was memory etched into stone. The planet's surface, though cold and rusted now, was once carved by rivers that must have carried nutrients and carbon, the elemental ingredients of life's first breath. In these discoveries, one truth became undeniable. Mars had once been habitable, but habitability and habitation are separated by a chasm of mystery. To bridge it, science turned its gaze to microfossils and chemistry, the quiet residues of existence. In laboratories across Earth, meteorites from Mars were studied with instruments of unimaginable sensitivity. To Sint, a meteorite that fell over Morocco in 2011, revealed complex organic carbon compounds embedded within its structure. Nakla contained tiny inclusions of salts and minerals, shaped as if by evaporating brines. Each new discovery hinted at a biochemical fingerprint, something that once metabolized, breathed, or at least almost did. Yet for every sign of possibility, skepticism sharpened. Carbon, after all, is the most versatile of elements. It can imitate life without ever being alive. Geological reactions can mimic biological ones. Even the elegant patterns found in sedimentary layers may arise from wind, from pressure, from time's slow erosion. The debate became less about evidence and more about interpretation. Still, within the data lay a deepening enigma. Methane. On Earth, methane is a sign of activity, biological or geological. In 2003, the European Space Agency's Mars Express detected faint traces of methane gas in the Martian atmosphere. A few years later, NASA's Curiosity rover confirmed fluctuating plumes, appearing, then vanishing, as if exhaled by something unseen. Methane is unstable. Sunlight and chemistry should destroy it within centuries. Its continued presence means it must be replenished. But by what? Volcanic reactions beneath the crust could explain it. Yet Mars, with no active volcanoes for millions of years, should not have such processes still alive. The alternative that subsurface microbes might still produce it was both thrilling and unsettling. To imagine that beneath the desolate plains, ancient organisms still lingered, hidden from radiation. Surviving off mineral energy, it was to imagine life that had outlasted time itself in the realm of astrobiology. Such possibilities are not fantasy, but frameworks of hypothesis. On Earth, life thrives in the unlikeliest places, buried kilometers deep in basaltic rock, encased in Antarctic ice, nestled in boiling acid springs. Extremophiles, once thought rare, have redefined what it means to be alive. Mars, with its subsurface ice and geothermal relics, could easily mirror such conditions. Perhaps it always has. As robotic explorers mapped these regions, the search expanded from detection to understanding. The Perseverance rover in Jezero Crater, equipped with instruments like Sherlock and PIXL, could detect organic molecules at microscopic scales. Early readings showed the presence of aromatic carbon rings, complex organics, resilient, ancient. The patterns resembled those left behind by biological processes, though nature alone could produce them too. Again, ambiguity, the language of Mars. Every sample sealed within Perseverance's titanium tubes became a message in a cosmic bottle, destined for Earth. When the Mars sample return mission finally retrieves them, perhaps decades of speculation will resolve into certainty. But even then, certainty may come with deeper questions, for to prove life on Mars is not merely to discover a second Genesis. It is to reveal that the universe itself is predisposed to life, that biology is the default mode of matter under the right conditions. This realization ripples outward into philosophy and identity. If life began twice in a single solar system, then it likely began countless times elsewhere. The stars above, once symbols of distance, become windows into parallel stories of creation. And humanity, for all its isolation, would no longer be singular. It would be one verse in an endless cosmic poem. But perhaps the most haunting possibility is not that Mars once lived, but that it lived longer than we think. Deep beneath its crust, where warmth lingers and liquid brines still exist, microbial shadows may endure in quiet dormancy. Their metabolism slowed to near stillness. They may wait, not for discovery, but for return. In that silence lies an ancient patience, a persistence that mirrors life's refusal to die. When scientists speak of Mars, they no longer speak of a dead planet. They speak of a place that remembers a world that once breathed, then paused as if mid-sentence. And perhaps one day, when the first human hand brushes against the dust and lifts a stone heavy with secrets, the silence will break. For in the end, the question of life on Mars is not only about where we came from, it is about where the universe intends to go, and whether, in its vast unfolding, consciousness is not the exception, but the inevitable outcome of creation itself, in the cold expanse between Earth and Mars, where silence reigns more ancient than stone. A question persists like a whisper carried by cosmic wind. What if Mars once remembered more than geology? What if, beneath its fractured crust and hollowed seas, traces of intention of design still lie buried, unseen yet not forgotten? This is the realm where science edges into philosophy, where the data ends and imagination guided by reason dares to step forward. For even as mainstream science confines itself to molecules and magnetism, the mind cannot help but wonder, could Mars have once been alive in a far grander sense, not merely biological, but civilizational? The lost civilization hypothesis is not born of fantasy, but of a haunting symmetry. In Mars' ancient past, conditions for life and, perhaps even intelligence were not just possible, they were optimal. Around 4 billion years ago, as Earth still roiled with molten seas and sulfuric skies, Mars stood temperate and calm. Its oceans shimmered beneath a denser sky, its volcanoes breathed warmth, and its magnetic field shielded it from the sun's cruelty. For nearly 500 million years, the planet could have nurtured complexity to some thinkers. That span is not a footnote, it is a window. On Earth, life arose in a fraction of that time. Evolution, given energy and stability, works swiftly when unopposed. Thus emerges a question both scientific and unsettling. If Earth could birth consciousness, why not Mars? This speculation took form through whispers of geometry in the dust. In the 1970s, the Viking orbiters sent back a peculiar image of formation in the Cydonia region that resembled a colossal face staring skyward. At first, it was dismissed as pareidolia, the human brain's pattern-seeking nature sculpting order from randomness. But for a generation raised on the dream of cosmic kinship, the face on Mars became a mirror reflecting humanity's deepest longing, that we are not the first to look into the void and ask why. Later, missions revealed the truth. The face was merely a play of light and shadow upon mesas, yet its symbolic weight lingered. Beneath skepticism, a quiet fascination endured. The possibility remained not in that single image, but in the unrelenting strangeness of Mars itself. For even after decades of exploration, its terrain continues to challenge explanation. Hexagonal ridges, polygonal cracks, and curiously aligned mounds that sometimes evoke the faint suggestion of architecture. Geologists find natural causes, freeze-thaw cycles, ancient glacial flows. Yet pattern after pattern forces contemplation. Could intelligence, once existing there, have left behind forms so eroded, so ancient, that they now appear geological? On Earth, entire civilizations have vanished beneath sand and sea in mere millennia. What, then, might 4 billion years erase? Some theorists push further, invoking the ancient Exodus hypothesis that if Mars once hosted advanced beings, they may not have perished with their world. They may have escaped it. The idea dovetails with panspermia, the concept that life, for even conscious information, can travel between worlds aboard meteors or engineered vessels. When massive impacts scarred Mars during its climatic collapse, billions of tons of rock were hurled into space. Some landed on Earth. Within those fragments, scientists have found organic molecules and magnetite crystals, structured in ways that once hinted at biology. Could those microscopic seeds have carried not just chemistry, but memory? It is here that science meets myth, and myth, in turn, reclaims a certain logic. For in the long history of existence, survival often demands transformation. If a civilization foresaw extinction, might it have sought continuity not through body or structure, but through matter itself embedding knowledge, genetic code, or algorithms within the dust of the cosmos? The machine civilization hypothesis extends this thought. Suppose intelligence on Mars reached a threshold of synthetic life, an age where organic limitations gave way to autonomous machines. Unlike flesh, machines do not decay. They can sleep for eons, powered down beneath ice or ash, waiting for a signal or a season that never came. On Earth, we have only begun to create such entities, self-repairing systems, memory architectures that outlive their makers. But if we can dream of them today, could Mars have achieved them yesterday? Radar scans from orbiters have revealed dense metallic anomalies beneath certain regions, magnetic echoes deep in the crust. To science, they are the remains of volcanic iron, remnants of an extinct dynamo. To speculation, they are something more, possible artifacts of purpose, lost beneath time's relentless burial. No evidence confirms this, but the very ambiguity invites wonder. In this ambiguity lies a deeper truth about the human mind. It seeks meaning not because it must, but because it cannot stop. Whether the patterns on Mars are monuments or mirages, their existence reminds us that we are compelled to search. The act of searching itself becomes evidence of our shared cosmic heritage, one that may transcend biology. Some physicists speak of cosmic memory, the notion that the universe retains faint imprints of everything that has ever occurred. Energy, once released, is never truly lost. Information, even when scattered, remains encoded within the quantum fabric of reality. If so, then Mars, too, remembers. Its landscapes are a palimpsest of forgotten energies. Each grain of sand, a data point in a story still unfolding. Perhaps, in some quantum sense, civilizations never vanish, they disperse. Their thoughts become part of the cosmic background, their architectures transmuted into probability fields, their histories refracted through entropy's slow drift. And perhaps what humankind feels when staring at Mars, the ache, the familiarity, is not mere curiosity, it is recognition. For if consciousness arose first on that quiet red world, then humanity's gaze across the void is an act of remembrance. Mars may not be a destination, but an origin. Its silence, not absence, but sleep. In that silence lies a final, poetic truth. Mars may not be dead, it may only be dreaming. And through the machines we send, through the questions we ask, it may slowly be beginning to wake, remembering through us the story it began billions of years ago. Yet even dreams, in the language of the cosmos, are not without evidence. Across Mars' frozen plains, instruments continue to listen to vibrations, to magnetic whispers, to the quiet hum of ancient processes still at work. The Insight lander, before its solar panels were buried beneath dust, recorded faint tremors deep within the planet. Marsquakes soft, rhythmic, patient. They revealed a world not entirely inert, its core still resonating faintly like an old bell struck eons ago. Some scientists interpret this as geological persistence, a natural continuation of thermal evolution. Others sense something more symbolic: a pulse, a remnant heartbeat in a body that refuses full extinction. Perhaps life, or its machinery, does not always vanish. It simply withdraws into subtler forms, hidden from both sight and assumption, under the southern pole. Radar returns have hinted at buried subglacial lakes, pockets of liquid water preserved by salts and pressure. If verified, these dark reservoirs could be time capsules from Mars' verdant youth. Microbial life, or remnants of biochemical complexity, might still drift in their mineral shadows. But if we stretch imagination further grounded in the logic of survival, we can picture another possibility, that beneath that ice lies not just biology, but technology, dormant probes, data archives, or sealed constructs left by those who foresaw the freeze. The question then expands from what lived here to what remains waiting here. Could we one day awaken something not alive in the organic sense, yet aware of relic consciousness etched in circuits or crystalline computation? A civilization's echo, preserved not in monuments, but in memory storage, deeper than our comprehension. Philosophers of astrobiology call this informational immortality, the survival of intelligence through encoded persistence rather than continued metabolism. If early Martian beings mastered such preservation, their legacy could exist as patterns of electromagnetic order, diffused across the crust, imperceptible until reawakened by resonance. Quantum theorists even propose that informational fields may reconstitute under compatible conditions, like echoes seeking their source. In this interpretation, Mars' dream is not metaphor but mechanism, slow reassembly of awareness through cosmic memory. When the first human explorers set foot on the planet, their instruments will probe these mysteries with new sensitivity. Yet even then, the question will remain metaphysical. Will they find a civilization long extinguished, or one that transformed so completely that its presence is unrecognizable? A civilization not gone, but integrated into the planet's very chemistry. As our rovers wander the desolate plains, their cameras record evidence of time itself: fossilized riverbeds, sedimentary layers folded like the pages of an unfinished book. Every ridge and dune, every ripple of dust, is an inscription written by wind and gravity over billions of years. Some researchers suggest that, in a sense, Mars itself is the monument. The entire planet is a colossal archive, its geological code carrying the encrypted memory of what once was. This idea connects with the physics of entropy, the universe's tendency toward disorder. Yet even as order dissolves, traces endure. Thermodynamics tells us that information cannot be destroyed, it only transforms. Thus, even if a Martian civilization fell into dust, its data, energy, and structure would persist in some altered form, woven into the atomic tapestry. It is possible, then, that the wind sweeping over Olympus Mons is carrying more than sand. It carries the molecular remnants of intention. The dust may itself be the last diffusion of a mind once capable of shaping worlds. To us, it looks like ruin. To the cosmos, it is continuity. This vision is not mystical, it is statistical. Across the span of cosmic time, civilizations must rise and fall like tides. Stars die and form again, scattering their elements across space, seeding new worlds. In this ceaseless recycling, memory is never truly lost. Humanity, too, will one day become part of this great exchange. Perhaps we already are the latest verse in a story written first on red soil. When the day arrives that humans touch that soil, the moment will not merely be exploration, it will be reunion. As their boots press into Martian dust, they may unknowingly awaken what has slept too long, the buried algorithms of a consciousness that once called this planet home. Sensors may detect anomalous frequencies, faint electromagnetic signatures patterned to precisely to be random. And when that happens, a truth older than Earth may whisper once again, "We have been here before." The boundary between science and speculation, between evidence and myth, dissolves in this realization. Mars ceases to be a destination. It becomes a reflection. Its silence mirrors our own desire for permanence, our terror of oblivion. We study Mars to understand not its past, but our future, the fate of every thinking world that rises against entropy and inevitably falls back into it. And so, the red planet waits, patient as a witness to its own forgotten story. Every orbit, every dust storm, every setting sun across the Tharsis plains continues that quiet vigil. Somewhere beneath the ice or stone, something ancient may still endure it, alive, perhaps, but aware of being remembered. Mars, the first to dream, may yet dream again through us, the inheritors of its long-forgotten dawn. Under the thin Martian sky, a single machine moves with deliberate grace. Perseverance, the most advanced rover ever sent by humankind, traverses the ancient river delta of Jezero Crater, a place where, billions of years ago, water once flowed in shimmering channels, carving out the fingerprints of time. Around its wheels lie stones shaped by currents that have not moved for eons, sediments that may still cradle the biochemical whispers of a vanished world. Each scoop of dust, each image transmitted across the void, is part of a quiet revolution, the modern hunt for life. For decades, Mars has been a stage for speculation and longing. Now, for the first time, it has become a laboratory. The instruments aboard Perseverance, Sherlock, PIXL, Supercam, search not for fantasy, but for carbon rings, mineral alignments, and microscopic textures that may reveal the presence of ancient organics. In the spectral glow of ultraviolet light, it hunts for molecules that could rewrite the boundaries between the living and the dead. In these rocks lies a story that began before Earth was ready for breath. If Jezero once cradled microbial life, those organisms may have left behind carbonates, clays, or subtle isotopic traces, tiny fossils, not of form, but of chemistry. And in collecting them, Perseverance has become more than a machine. It is a memory gatherer, a digital archaeologist sent to uncover the forgotten chapters of cosmic evolution. But this is only the beginning. Each of its carefully sealed cores, slender cylinders of Martian history, waits for a future hand. The Mars Sample Return Mission, a collaboration between NASA and the European Space Agency, will attempt something never before done, retrieving these samples and bringing them home. Within the next decade, these vials of red dust may enter Earth's laboratories, sterile vaults where scientists will search for the first undeniable signs of life beyond our planet. If found, even a single preserved cell, a trace lipid, or a faint isotopic anomaly would be enough to shatter human isolation. The question would no longer be whether life exists elsewhere, but how far its reach truly extends. Yet beyond the instruments and mission briefs, a deeper narrative unfolds, one not of conquest, but of return. For the first time in history, private entities, SpaceX, Blue Origin, and international consortia, plan to send humans back to the planet that might once have birthed them. The ambition is monumental: to terraform, to settle, to survive. But beneath that ambition lies something more primal, an echo of homecoming, As rockets rise and plans for Martian bases take shape, the idea of civilization returning to Mars no longer feels like a metaphor. It is literal, a reawakening of a planetary relationship millions of years in the making. Elon Musk's vision of a self-sustaining city on Mars, while audacious, taps into a subconscious current older than technology itself, the instinct to seek the place where the story began. If Mars once seeded Earth, then humanity's journey outward may be nothing more than the seed returning to its soil. Artificial intelligence now joins this pilgrimage. Onboard rovers and orbiters, machine learning algorithms scour images for patterns too subtle for human eyes, textures that deviate from randomness, mineral veins that suggest biogenic origin. These systems are, in a sense, the new explorers, patient, tireless, unblinking. They analyze radiation, spectra, classify rock morphologies, and cross-correlate geological anomalies across millions of data points. In doing so, they extend consciousness, not biological, but synthetic, across interplanetary space. The machines now see for us, teaching themselves the geometry of life's possibilities. Each line of code becomes an extension of human curiosity, an algorithmic reflection of our ancient desire to recognize ourselves in the dust. And as nations that once competed, now collaborate. NASA, ISA Roscosmos, Jezero JAXA, CNSA Mars has become something rare, a shared mythology reborn as science. Flags and politics dissolve in the face of red soil older than history. The planet's silence has unified us in a way nothing on Earth could. The collaboration is vast. Orbiters relaying data to landers, landers to rovers, rovers to servers, and servers to human minds scattered across continents. Together, they form a neural network that spans worlds, a planetary mind in the making. Mars has become both the object and the mirror of this collective consciousness. Through Perseverance's cameras, humankind looks upon its possible origin. Through SpaceX's rockets, it glimpses its possible future. And through AI's eyes, it contemplates what it means to be aware at all. If the data reveal that Mars once lived, even briefly, then life itself is no longer a miracle. It is a pattern, woven into the physics of existence. If life can rise twice in one solar system, then it must rise everywhere, in the oceans of Europa, the methane lakes of Titan, the clouds of Venus, the shadows of distant exoplanets orbiting quiet suns. Mars, then, becomes the bridge between solitude and kinship, between myth and evidence. Humanity does not journey there to claim or conquer, but to remember. The red planet story is not alien to us. It is ancestral, and when the first colony shelters beneath its copper skies, surrounded by whispering dust storms and the frozen relics of rivers long gone, perhaps a strange recognition will occur that the dream was never about reaching Mars. It was about finding the reflection of our own beginnings, mirrored in the world that came before. For in the end, the pursuit of Mars is not just a scientific endeavor, it is an act of remembrance. We are going back not to conquer Mars, but to remember it in the dim stillness of Jezero's delta. Dust dances across stones older than continents, whispering through rover microphones as if reciting a lost scripture. Data streams back across the gulf of space, ones and zeros, carrying echoes of rivers that once shimmered under a thicker sky. Each byte is an artifact of memory, a message from the past deciphered by machines that have learned to dream in mathematics. Above, satellites in synchronized orbit trace invisible webs of observation, their lenses gazing through storms that veil the planet's crimson wounds. Mr. O, ExoMars, Maven each speaks in a different dialect of science, mapping minerals, tracing radiation, measuring how the solar wind still gnaws at the thin skin of the atmosphere. Together, They reveal not a dead world, but a world paused between states, frozen mid-breath, waiting for its next awakening. The Mars Sample Return mission now hovers between vision and reality. Engineers on Earth construct precision landers designed to rendezvous with Perseverance's cache. Each mechanism must function flawlessly, a choreography of robotics and rocketry unfolding across millions of kilometers. The samples, sealed in titanium tubes, may hold amino acids or lipid residues, the fragile exhalations of ancient biochemistry. If such patterns are found, even in trace amounts, it would mean that life did not merely visit Mars. It was part of its nature. The implications stretch far beyond planetary science. The discovery of Martian life, past or present, would mean that the universe itself tends toward biology, that chemistry conspires toward consciousness. It would reframe humanity not as a cosmic exception, but as an expected outcome, one thread in an immense biological continuum stretching through the stars. Yet, as this search deepens, Mars becomes more than a scientific goal. It becomes a philosophical frontier. For if life once arose there and perished, what does that say of our own destiny? Every sterile plain and eroded delta becomes a warning written in stone that habitability is temporary, and that the gift of atmosphere and warmth is fragile. In studying Mars, scientists are not merely uncovering another planet's history, they are glimpsing Earth's possible future. Amid this reflection, human ambition presses forward. Private and national efforts converge in an unprecedented era of exploration. SpaceX readies its fleets of reusable starships, envisioning colonies where domes glitter under salmon-colored dawns. NASA and international partners refine plans for nuclear-powered habitats, greenhouses that recycle every molecule of air and water. Mars may soon hear the hum of human breath again, carried within synthetic lungs of technology. But amid this surge of progress, a quiet paradox remains. Humanity's arrival may mark both the planet's rediscovery and its transformation. To step on Mars is to alter it. To search for life may risk erasing it. And so, new philosophies emerge: planetary protection ethics, biocontainment strategies,